Well, good morning, everybody. Yesterday I had the privilege of driving down to Owensboro. That's why Matt and I kind of switched days this week. Left pretty early and got down here, and I showed them a map, and it's the map you're looking at right here, which is the total precipitation ranks by climate district starting at the beginning of this new year. And you can clearly see that across Kentucky, it's been one of the wettest years on record. In fact, in two of their climate reporting districts, it is the wettest. And I'll be honest with you, things are extremely green. Parts of the crop look very good. A lot of the crop is still underwater, though. There's a lot of very, very saturated fields, major delays. And the farther you come down the Ohio Valley toward the Boot Heel, down into parts of Tennessee, Arkansas, there's a lot of prevent plant acres that are going to be in this area because of too frequent rainfall, rains that hit an area after planting, drowning out the fields, and just extremely large precipitation events. As you look at this, you start to find some other things. This has been a worry that we've had since winter, that we would be struggling to see consistent rains across this section of the central United States in the Corn Belt. And overall, since the start of the new year, we've had a drier signal here. That's why this area is still on the drought monitor. But, I was talking with my boss's boss last night, and he's been on a tour across Iowa. And he made a comment. He goes, "There's a lot of people in Iowa that are glad that you were wrong about the drought risk here." And I said, well, we have to be clear that there is still a drought risk on the table for the Western Corn Belt given the current global setup. But I'll be honest with you, some of these rains that we've had have been critical. Now, it's going to make a story for the whole country here. I know I just picked on the Mid-South and the Midwest. But the thing that we need to be thinking about as we go forward, you get into summer, okay? We start to lose the strong teleconnections. What that is that's like the relationship between, the jet stream, the MJO, the AO, the NA, all of those features in the atmosphere we constantly observe that tell us, how the precipitation patterns might evolve as low pressure and high pressure systems move. Well, you get into summer and you're just in pure convection mode for a lot of the country. We wait on a monsoon in the Southwest because it has been very dry here over the long haul. I know recently there's been some big storms down. Phoenix back in May picked up, an inch of rain. But what I'm saying in this particular setup is we're just moving into a time period where the atmosphere is rapidly overturning all the way until we get to fall. All right. So if that's going to be the case, we have to just look at if there's the ingredients together to make those storms. And so much of that discussion is going to come down to understanding this. Now, what I did was I went back to April 1st, all the way up until the most recent data available in this reanalysis set, And I said, just show me the pressure patterns. I want to see where the two big high pressure cells that typically flank North America have been. Because the top question, the moment I started speaking, I asked the group, I said, what do you want to know? You tell me what you want me to focus on. And the concern here is that they've been flooded out in spring. It's going to get extremely hot very, very soon. And then the moisture is going to shut off. They're going to steam a crop first and bake it second. And they're worried. And I get that worry because if it can just stay wet, this crop will do okay. It's kind of crazy to think that, but don't turn it off. The crop is adjusted to that as it grows. All right, so what we talked about was I said, all right, you just need to watch this. Since, April 1st, the Bermuda high has been living right about where it likes to live, somewhere between the Azores and Bermuda, right here. So this is what's kept flow coming around, opening the Gulf. There's been a Pacific high. It's kind of got two pieces to it if I just use Hawaii as an anchor. There's been a piece here and a piece there. That's shoved the jet stream pretty far to the north, okay? But overall, the Pacific high has been behaving. And when I say behaving, I mean it's stayed in the Pacific. For the most part, if you go back to 2021, the Pacific high lived over the Pacific Northwest, giving us incredible heat waves. So we've seen these two subtropical highs, which are the most important components to the flow going forward. They've been in pretty good position. So what we have questions about is, are they going to stay there? Because if they do, take a look at the resulting wind vector flow in the low levels of the atmosphere. You get flow like this, and you get flow like that. And what we have to watch out for is a few different things. If I'm on the West Coast, I'm going to watch out to see if this high moves there. And if it does, it gets very hot, it gets very dry. We have a delay in the monsoonal season. We have problems. I know that summers are hot and dry in the West anyway. I'm just saying that that's the one that puts us way over the edge. We have long duration excessive heat. I'll watch the Bermuda High. Does it slide into the southeast? If it does, the southeast is in drought, and we're going to flood out the midsection of the country. I'll watch the Bermuda High to sag over toward Africa or the North Atlantic. And if that happens, instead of having flooding here, we flip the whole script. It gets very hot and dry in the midsection of the country, and the southeast stays wet. So there's always a trade-off given the size of these large high-pressure cells and the size of the United States. So let's go have a look at them. Bermuda High, there it is right now. Okay, I'm just going to click play on this animation from the European model. We're just watching it. It just seems to stay there. And so you can see the flow coming around it through the Gulf, transporting moisture into the central United States, the southeast United States, up the Mississippi Valley. And it just maintains its position through the next week, out to day 10. See it? It's just sitting right there. And because of that, because that seems to be a more permanent feature, let's just pause this when it restarts. Until that Bermuda High begins to drift, you're not going to see a pattern change. In the Pacific, take a look. There it is. Now watch. As I click play, the Pacific High just orbits here. You get very strong winds just off the coast. This is very common. We do see some tropical development down here. I'll tell you more about that in a second. But there are lows that are moving through the Gulf of Alaska. But overall, the Pacific High is maintaining its mean position somewhere out here, north and east of Hawaii. Now, it's not going to be there all summer. It will move. It'll meander. There will be times when both of these high-pressure cells shift position, and that's when we start to build in worry about where things are going to go and why they're going to go there. But the net effect of having all of that is that every day we're going to watch a satellite animation that looks something like this, where there are large convective systems that pop up in the mountains. They're going to be in the southeast. We're going to have storms that are in different places at different times, but they're going to be in the plains in the Midwest. And it's going to gather toward the north and east. That's just the direction systems tend to go because of the prevailing winds across North America. Now, we do have still some smoke in this, as you can see. And there were some big storms yesterday, in parts of Iowa and parts of Nebraska, and also just lining, the front range of the Rocky Mountains in the high plains. Then we had a deeper complex. There's a low sitting underneath this that's spinning its way up toward the Mid-South later today, and more storms with very heavy rain in the southeast. But when we keep those high-pressure cells kind of just off our coasts, we don't tend to see a situation where we build big droughts. That's it. I mean, that's really the story here. So with all that being said, let's go have a look at the current radar. So this is an animation starting last night. You can see, look at the deep storms down here. I was talking to a good friend of mine, his name's Rocky, down here in Baxley, Georgia. And again, he got hammered with more and more rain. You can see coming out of parts of Texas, Louisiana, Arkansas, Oklahoma, bigger storms, heavier rain. Some of the storms that went through Iowa were hailers last night. But there's a boundary sitting in through here on which we're expecting to get more storms. Matt talked to you about it this week, about these ridge riding events that are coming through, and even coming out of parts of Idaho into Montana. Look at that. There's some good moisture in places that really need to see it in the western, high plains here. Okay, going forward, let's just get a quick rewind on the precip recently. So this is the last 48 hours of total accumulated precipitation. And I wanted to focus in on a couple of areas. First of all, this was great to see these storms coming through this area. We watched down south all across the Cotton Belt, which only has like 6% of its total area in drought right now. More storms coming through here. If we take a closer look down there, though, some of these storms in the last 48 hours dropped a tremendous amount of rainfall. We saw 3, 4, 5-inch rainfall amounts, and also more hail out of these storms, while the storms that came right off the front range here into the high plains were also capable of putting down some small hail, but also some heavier rainfall totals. Storms that went through parts of South Dakota into southern Minnesota and Iowa, they were a bit stingy with the rainfall. In other words, we had some local places picking up very heavy rainfall amounts, but we discussed this, right? That's what summer thunderstorms do. They do not share rainfall uniformly. They tend to hyper-local deliver heavy rainfall amounts. But some of these produced some hail last night, so there was some damage to some crops in this particular area. I wanted just to show you, let me zoom out so you can see the color bar there. But as you can see, we had some places that picked up, hail that was, anywhere from a half-inch in diameter to some places well over an inch. A couple of reports here were much larger. So this is some of the radar estimated hail, and you can kind of see it back into parts of South Dakota and Nebraska as well. But overall, take a look at the last week. That's the last 7 days when you use the MRMS mesh product. That's a way by which we use the radar to detect hail and map it out. And And the southern plains have been just beat to pieces with respect to hail. And of course, hail is much above average on the national numbers right now. So I just wanted to kind of give you some of that perspective before we get back into this narrative. And the narrative is here. I mean, this is what's going on. We have the Bermuda High there, and we have the Pacific High sitting over here. And all around that Bermuda High, this is opened. And yes, it's getting hot in places, and it was very hot yesterday in the west and the south. Well predicted. But overall, the west would need to worry if this thing just came and settled itself into the northwest. But that's it. While these two high pressure cells continue to flank North America in the way they do, all right, where are we not building high pressure? In the middle or on a coast. I mean, it's just they're staying away. Now, looking at this, there's a couple of neat things to see. Some of this flow leaves Africa and makes it all the way into the Caribbean and into the Gulf and then up into parts of the lower Mississippi Valley, the red, white, Arkansas, this whole region. And I went looking again just to see if there's any big Saharan dust plumes. There's not. There's some. If you just watch the animation here for the next 10 days, there's some Saharan dust following that track moving into, the United States. But we'll keep an eye on this late in the time period. Seems to be quite a bit of dust getting stirred up, sand, getting blown off of Africa going forward. You also probably noticed that there's something spinning up down here off the coast of Mexico and some parts of Central America. There is more tropical development possibly happening down there. I know Matt covered it this week for me as well. 90% chance of some development here. We got behind it a 20% chance. The East Pacific has been quite active in this early season. And some of the forecast models are taking that. And once again, more keeping the trajectory of development out toward the Pacific Ocean, mainly because of the position of these big high pressure cells, right? So if we want to curl one of these in here, you've got to bring high pressure into this area. That's just, they're always responding to high pressure. So low off the coast, high over here. We'll take anything that develops in the tropics and just shove it in between. That's what we saw with Alvin. So again, we just step ourselves back into this narrative, and we're looking at the flow around high pressure, the opening of Gulf moisture, and its transport, and where we're going to be able to see, if you just look at this, okay, see that low-level moisture transport? Now watch, as I step you up higher in the atmosphere, over the top of it is this, okay? And so what's happening is the low levels are coming in, the high levels are coming over the top, and then that effect is you're creating a scenario by which you can build storms that then develop, and they develop down into the more high moisture content region. That's the setup of a summer thunderstorm pattern. So this is what it looks like. We have just repeated chances on Gulf moisture of storms in this area. You then have a corridor that opens here. There, these storms develop as the northwest flow comes around, and they just build. And that's the concern as we go forward. Now there's an issue with this. Parts of the Canadian prairie seem to be getting left out. You look in here and see a whole lot of green. And you have to remember that some of these storms in through this area will miss key growing areas. They just won't hit. Your neighbor down the road will get 1.5 inches of rain, and you'll watch it, and you'll miss it. That happens every single summer. And we also start to notice that in this particular pattern, we open up to a broader area of dryness in parts of the central plains of the United States. And with that particular setup, this is what we tend to find. We tend to find that the atmosphere is more preferentially giving that rainfall through corridors like here and then down in the southeast than more in the southern plains. We also want to just keep an eye on anything that sneaks under the larger ridges building. Maybe some lows coming into this area, delivering some moisture here in the next 10 days. But that's the setup we're talking about as we just think where this pattern's going forward. Now, there is one other component to this I do want to talk to you about, and that is we've watched the artificial intelligence forecast model, which I do like to look at for its ability to resolve the upper level height pattern. It has preferentially dropped more troughs into the northwestern United States and taken that Pacific high and built it into this area. So what that ends up doing is now this is not surface pressure, the upper level pressure patterns are putting more of the upper level high pressure here. So we are getting ridging in this part of the country, which is going to bring in some heat. But for most folks in that section of the United States, we need some of this heat to get into this area. But I want to bring that up because that's going to give us a forecast model that's going to be a bit more stingy on the thunderstorm activity given the size of this ridge and the depth of the trough in the northwest. But if I flip models on you and just now look at animation, That was the artificial intelligence. This is the dynamical model. This is called the European ensemble. So it's a 51-member ensemble. We're looking at the troughs and ridges. So in the near term, that's the low that's coming out of Texas toward Missouri. I'll show you the rainfall for that in a minute. Broader trough trying to develop along the west coast while a ridge opens up this weekend into early next week in the midsection of the country. You'll see the heat with that. But this is what it takes. You build in that ridge, and what you end up getting are these little tiny short waves that just come right over the top, all associated with some sort of trough. Here it'll move, okay? And those waves initiate thunderstorms, and they just cascade and build through the heat and where the moisture is, because the Gulf underneath is still opened. And that's what we're going to keep an eye on. Now, this is next Thursday getting into next Friday, and there's going to be some really warm temperatures coming in with this pattern. But the the European ensemble also sees ridge going in here, trough along the west coast, and broader ridging in this area. But the thing about it is, in the upper levels of the atmosphere, this has yet to produce just an area of massive high pressure in this region. This is not blocked flow. If we were talking about block flow, I'd be going, oh, look, omega block. Or we'd be talking about a high, well, let's redraw it, a high, sitting over a low. So the flow would come in and around and dip down like that. And we're not there. This is still a flow conducive to thunderstorm development, which again walks back some of the longer term drought narrative that we've had for some time. So let's take a look at what it all does. So just a hair before 5 a.m. or 6 a.m. this morning, we do have excessive heat watch down here in parts of Arizona, Southern California. Well forecast there. We have air quality issues across the north, still with some Canadian wildfire smoke. And you can see the flood watches and the warnings that are out for parts of Texas getting into Arkansas, Louisiana, and this corner of Oklahoma. Now, as we look at the flood risk today, take a look at these bottom three maps. Here's today, tomorrow, and then getting into the weekend. This is Saturday. We're watching this slow-moving low really increase our threat of very heavy rainfall. We will see a lot of thunderstorm activity across the United States today, again on Friday and Saturday, with a lot of these lining up in the plains, as you see here. Right, look at that, hugging just the high plains, getting up toward the higher elevation of the mountains. And with that tells me this configuration is like, all right, Eric, you better start really hammering home the message on these ridge riders. So let's get in there and have a look at what they might look like. I'm going to use the high-res NAM today just to get a glimpse at this. But what I want you to notice as I play this forward is, one, the low moving out of Texas toward Missouri. There it is. But look at the storms just popping in the model here later today. Or along the boundary that's stretched farther to the north. That's much cooler north and much hotter to the south here. And then the southeast, just more convective activity. It's that time of year where every day, if the Bermuda high is sitting here, can you see it, by the way? I know I'm not mapping pressure, but imagine it's there. Watch the flow in these storms. Let's go backwards, forwards. See it? And every day, that gives us this 30 to 50% chance of storms that stretch from Florida back to Mississippi and Alabama, all the way through the southeast up to the mid-Atlantic. And these complexes of storms are not we can't predict exactly where they're going to be, when they're going to be there, but we know their atmosphere is ready to make them. So we're going to watch through the next several days how that's going to play out. Okay, what I'm going to be watching for is those high pressure cells, and over the next several weeks, do they just stay put? Because if they do, you'll continually see maps like this one. This is a map of precipitable water. Now we're just going to play it quickly, but these colors represent high moisture content air. And if the Gulf is open, we keep it there. Now have a look. The European model next Thursday is dropping a kind of a nice dry intrusion into the Great Lakes states down into the eastern Corn Belt. Again, this is next Wednesday, Thursday, going into the northeast. But then it just opens up. A surge opens right back up. And rather than walking through the precipitation intensity maps, which you can do at any time on the site, I just want to get to the end result. The end result is here. This is the total accumulated precipitation, from the European model. As we play it forward, you'll just notice where the convection's going to kind of light up and fill in gaps and start to make precip. Now, there's one area that I'm concerned about, and I'll just take you back. This is a 90-hour forecast. There's kind of this corridor in through here and then an edge to this. See that? And then to the north of it, a drier area. And so those, if you wanted to watch three areas to see if the storms kind of fill in those pockets, that's what I would be keeping a close eye on. We can also see it when we just look at the probability maps. Here's the chance of getting an inch over the next 7 days. And again, there's just kind of this corridor in through here we keep identifying, plus a western edge that seems to be drier. And then you can see, this part of the Canadian prairie having lower probabilities of getting those higher rainfall totals. But in between, we're looking at pretty decent chances of getting heavier rains. Now, what about out there into week 2? I'm going to come back to this idea again of looking at the statistical model, that's the artificial intelligence, versus the dynamical. Our AI model is much more aggressive out there the first Sunday after the solstice, okay, at dropping a broader trough into the west and making this ridge much larger. Now, just a general rule of thumb is, and it might be difficult for you to see, but find the 580 line or the 5,800 meter line. So I got a label on it right there, which means if we just trace it around, okay, that line goes way up here. And if the AI model is right, that means we'd start to see our summer ridge riding thunderstorms move a bit farther to the north. And if that high pressure cell builds in, this could give us not only very hot temperatures, but much greater risk of not getting the storms. So I just want you to be aware that there are some models out there that are giving us that view. Now, at this particular point, okay, if you take a look at all 4 of our week 2 outlooks, see them all here, you do start to see that in the AI and in the ensembles, okay, there's some dryness that keeps showing up in pockets throughout the central part of the United States. And as we work our way through the rest of June, we just need to be observant of the model forecast of that and then what actually happens to understand if we start to build in this risk, this problem that we had this discussion about yesterday. Does this just flip over at some point and we get away from this because the high pressure cells that flank North America move? I mean, that's going to be it. Now, I do know that when this bigger ridge comes in, it is in all the models, that it will give us a better chance of getting quite warm. And the risk of high temperatures, this was out from the CPC yesterday. They're keeping an eye out there right around the solstice for some very warm temperatures in the central United States. Okay, there's a slight risk as you look at this particular area. Now, yesterday was an interesting day because of where we saw very hot temperatures get into Nebraska and Iowa, just as one example, while much cooler to the north. The storms initiated on that boundary. Cooler in the southern plains simply because of cloud cover. But look at the southwest, 108, parts of like where I was just last week at this time, Phoenix 108. We've got very much hotter temperatures coming in right now. It's even going to get hotter than this. So just have a quick look at yesterday's highs and then remember this. We need the heat on this crop. If you go back to mid-May and just run it through this point in June, we've got numerous locations here that are cool across a broad section of the United States. Now, if you're growing crops in this area, we don't want this, right? I mean, we want early season heat. We want the map to look like this in July. But this is where we've gotten our cooler weather so far this year. It's been very hot in Florida, very hot along the Gulf Coast and in the southwestern United States. And as we kind of see where the temperatures are going forward, look at this today, 109 in Phoenix, according to the National Digital Forecast Database. We're cooler in here because of cloud cover, cooler farther to the north here on the other side of the front, plus there's some smoky skies in here. Right in between, look at that ribbon, all the way to the east coast of temperatures going to be touching 90 in this area. As we play it forward, this is getting into Friday and then Saturday. A lot of heat coming into the plains. Very hot down in the southwestern United States, 110 in Phoenix. And we play it out there. That's Sunday into Monday and Tuesday. And overall, just to see near normal to warmer than normal temperatures in this area, we need it. This area needs to get this heat in place. So that's next Tuesday. Let's go out to next Wednesday just to complete this 1 week outlook. And then watch the temperatures in the ensembles. That's the next 5 days. You can see that same pattern we just talked about. Okay. And as I slide out there, day 5 through 10, we do start to see much more broader warmth kind of coming into the central U.S., getting over to the northeast, anchoring in parts of the southwest. The jet stream is displaced north, but the high pressure cells are behaving. They're staying close to our coasts. So we're wetter and therefore cloudier and therefore cooler than average. But remember, cooler than average in south central Texas is still deep into the 90s. So I don't think of this as being pleasant, in my opinion. As we go from day 10, which gets us past the solstice, all the way out there into that first full week of our official summer astronomically, we see quite a bit more heat here as that ridge that we talked about in the upper levels of the atmosphere sits in this area. So it's just kind of completing a narrative here overall. Okay, I do want to make note, though, that the AI model has the biggest ridge, right? And as you look at the temperature anomalies, the 22nd through the 27th, it is very hot in this area. So this is a flip, right? This is the area I just showed you a moment ago that's been so cool, for a while. And now what we're doing is we're seeing the models aggressively bring in some heat. You keep the Gulf open, it gets hot and stormy. So we finished the narrative today with where we started. What are some of the models suggesting about those high pressure cells? So this is not a map of temperature, it's a map of pressure. So right now, over the next 7 days, the Bermuda high is there, but its highest pressure is there. The Pacific high's highest pressure is here. We talked about that, right? Now, as we move this forward, I just want to watch to see if these areas begin to drift away. So here we are getting into this. Let's see. Here's fully week 2. Let's get out there into week 3. And at that particular point, okay, the highs are still anchored here and here, but I do see a lot more higher pressure by the start of July, maybe moving a bit more into the North Atlantic. It's not as though it's a fully displaced, lost Bermuda high, but the Pacific high is living somewhere there. And as we play it beyond that, getting into July, you start to see a lot of low pressure here, but this is likely due to heat more than anything. You can drop pressure by increasing temperatures. And these subtropical highs, they are showing something here and here. Now, what I mean by that is displacement. It's not hugging the coast. They're kind of moving away. Now, the European model's been doing this for a long time, right? And that's why that 30-day outlook, if we just take you out there, I don't know, let's go to July 21st. So this is one full month of astronomical summer. As the high drifts, it's keeping better moisture east and not in the central United States. Now, we've watched the European model attempt to predict dryness in Texas and Oklahoma and Arkansas and Kansas for weeks, and it's not manifested itself, broadly speaking. But I just want to watch. You know what to watch with me now. So there's, of course, other models to examine, and we're going to finish up with that one. This is the CFSV2. Now, as I blow this up, June 26th to July 2nd, I still see, take a look right there. There's still, look at these vectors. There's still moisture transport. There's still the Pacific high living here. See those? But as we transition into July, you wouldn't call this strong flow anymore. And the Pacific high seems to be just drifting a bit farther away from the west coast. And maybe the Bermuda high, I drew that arrow the wrong way, sorry. Trying to just figure out if it's over here. Can you kind of see this flow with lows here? That's going to be something to watch. But until we get there, there's not a narrative. So I don't want to pretend that I'm seeing drought rapidly rebuilding itself back in until there's stronger evidence that these high pressure cells are leaving. So we'll finish just with that same model's outlook for June 26th to July 2nd. That's the precipitation rate, okay, millimeters per day. And this is the July 3rd through July 9th. So we're just going to look at the maps, and we're going to kind of leave it there. So we know what we're looking for. Let's just monitor it carefully together, and we'll just talk tomorrow. Hope you have a good rest of your day, and we'll talk then. Thanks.